AC voltage applied to a resistor. Objective questions. Question 1. When an AC voltage is applied across a resistor, the current through the resistor A. leads the voltage by 90 degrees. B. lags the voltage by 90 degrees. C. is in phase with the voltage. D. is independent of the voltage. Answer. C. is in phase with the voltage. Question 2. The power dissipated in a resistor connected to an AC source is given by A. P equals VI. B. P equals VI cos phi. C. P equals I squared R. D. all of the above. Answer. D. all of the above. Question 3. The RMS value of an AC voltage is A. the peak value of the voltage. B. the average value of the voltage. C. the effective value of the voltage. D. none of the above. Answer. C. the effective value of the voltage. Question 4. The relationship between peak voltage V and RMS voltage V is A. V equals V. B. V equals V by square root 2. C. V equals square root 2 V. D. V equals 2 volts. Answer. B. V equals V by square root 2. Question 5. A resistor of 100 ohms is connected to an AC source with a peak voltage of 200 V. The peak current through the resistor is A. 1A, B. 2A, C. 1.4, 1A, D. 2.8, 2A. Answer. B. 2A. Question 6. The power factor of a purely resistive circuit is A. 0, B. 0.5, C. 1, D. Depends on the frequency. Answer. C. 1. Question 7. The average power dissipated in a pure resistive circuit connected to an AC source is A. 0, B. half the maximum power, C. equal to the maximum power, D. double the maximum power. Answer. B. half the maximum power. Question 8. A resistor of 50 ohms is connected to an AC source with an RMS voltage of 110 V. The average power dissipated in the resistor is A. 242 W, B. 121 W, C. 484 W, D. 605 W. Answer. A. 242 W. Question 9. In a purely resistive circuit, the current and voltage are A. in phase, B. out of phase by 90 degrees, C. out of phase by 180 degrees, D. none of the above. Answer. A. in phase. Question 10. The heat produced in a resistor connected to an AC source is given by A. H equals I squared RT, B. H equals V squared T by R, C. both A and B, D. neither A nor B. Answer. C. both A and B. Would you like more questions or do you have any other? Representation of AC current and voltage by rotating vectors. Objective questions. Question 1. A rotating vector used to represent an alternating quantity is called A. Phasor. B. Vector. C. Scalar. D. Waveform. Answer. A. Phasor. Question 2. The length of a phasor represents A. the frequency of the alternating quantity, B. the peak value of the alternating quantity, C. the RMS value of the alternating quantity, D. the phase angle of the alternating quantity. Answer. B. the peak value of the alternating quantity. Question 3. The angle between two phasors represents A. the frequency difference between the two quantities, B. the amplitude difference between the two quantities, C. the phase difference between the two quantities, D. the time difference between the two quantities. Answer. C. the phase difference between the two quantities. Question 4. In a purely resistive circuit, the phasor representing the current and voltage are A. in phase, B. out of phase by 90 degrees, C. out of phase by 180 degrees, D. none of the above. Answer. A. in phase. Question 5. In a purely inductive circuit, the current phasor lags the voltage phasor by A. 0 degrees, B. 45 degrees, C. 90 degrees, D. 180 degrees. Answer. C. 90 degrees. Question 6. In a purely capacitive circuit, the current phasor leads the voltage phasor by A. 0 degrees, B. 45 degrees, C. 90 degrees, D. 180 degrees. Answer. C. 90 degrees. Question 7. The power consumed in a purely inductive or capacitive circuit is A. maximum, B. minimum, C. 0, D. depends on the frequency. Answer. C. 0. Question 8. the impedance of a circuit is represented by A. a phasor, B. a scalar, C. a vector, D. a complex number. Answer: D. a complex number. Question 9. The power factor of a circuit is given by A. the cosine of the phase angle between voltage and current, B. the sine of the phase angle between voltage and current, C. the tangent of the phase angle between voltage and current, D. the cotangent of the phase angle between voltage and current. Answer: A. the cosine of the phase angle between voltage and current. Question 10. A phasor diagram is used to represent A. the magnitude of alternating quantities, B. the frequency of alternating quantities, C. the phase relationship between alternating quantities, D. the power consumed by alternating quantities. Answer: C. the phase relationship between alternating quantities. AC voltage applied to an inductor. Objective questions. Question 1. When an AC voltage is applied across an inductor, the current through the inductor A. leads the voltage by 90 degrees, B. lags the voltage by 90 degrees, C. is in phase with the voltage, D. is independent of the voltage. Answer: B. lags the voltage by 90 degrees. Question 2. The opposition offered by an inductor to the flow of alternating current is called A. resistance, B. reactance, C. impedance, D. conductance. Answer: B. reactance. Question 3. The inductive reactance XL of an inductor is given by A. XL equals 2 pi FL, B. XL equals F by 2 pi L, C. XL equals 1/2 pi FL, D. XL equals 2 pi L by F. Answer: A. XL equals 2 pi FL. Question 4. The power dissipated in a pure inductor connected to an AC source is A. maximum, B. minimum, C. 0, D. depends on the frequency. Answer: C. 0. Question 5. The voltage across an inductor leads the current through it by A. 0 degrees, B. 45 degrees, C. 90 degrees, D. 180 degrees. Answer: C. 90 degrees. Question 6. The impedance of an inductor is given by A. Z equals R, B. Z equals XL, C. Z equals square root R squared plus XL squared, D. Z equals 1 by XL. Answer: B. Z equals XL. Question 7. The power factor of a purely inductive circuit is A. 0, B. 0.5, C. 1, D. depends on the frequency. Answer: A. 0. Question 8. An inductor of inductance L is connected to an AC source of voltage V and frequency F. The current through the inductor is given by A. I equals V by 2 pi FL, B. I equals 2 pi FL by V, C. I equals V by L, D. I equals LV. Answer: A. I equals V by 2 pi FL. Question 9. The energy stored in an inductor is given by A. 1/2 L I squared, B. 1/2 CV squared, C. Li, D. CV. Answer: A. 1/2 Li squared. Question 10. Inductors are used in circuits to A. oppose changes in current, B. store electrical energy in a magnetic field, C. filter out high-frequency signals, D. all of the above. Answer: D. all of the above. Would you like more? AC voltage applied to a capacitor. Objective questions. Question 1. When an AC voltage is applied across a capacitor, the current through the capacitor A. leads the voltage by 90 degrees, B. lags the voltage by 90 degrees, C. is in phase with the voltage, D. is independent of the voltage. Answer: A. leads the voltage by 90 degrees. Question 2. The opposition offered by a capacitor to the flow of alternating current is called A. resistance, B. reactance, C. impedance, D. conductance. Answer: B. reactance. Question 3. The capacitive reactance Xc of a capacitor is given by A. Xc equals 2 pi Fc, B. Xc equals F by 2 pi C, C. Xc equals 1/2 pi Fc, D. Xc equals 2 pi C by F. Answer: C. Xc equals 1/2 pi Fc. Question 4. The power dissipated in a pure capacitor connected to an AC source is A. maximum, B. minimum, C. 0, D. depends on the frequency. Answer: C. 0. Question 5. The voltage across a capacitor lags the current through it by A. 0 degrees, B. 45 degrees, C. 90 degrees, D. 180 degrees. Answer: C. 90 degrees. Question 6. The impedance of a capacitor is given by A. Z equals R, B. Z equals XC, C. Z equals square root R squared plus XC squared, D. Z equals 1 by XC. Answer: B. Z equals XC. Question 7. The power factor of a purely capacitive circuit is A. 0, B. 0.5, C. 1, D. Depends on the frequency. Answer: A. 0. Question 8. A capacitor of capacitance C is connected to an AC source of voltage V and frequency F. The current through the capacitor is given by A. I equals 2 pi FCV, B. I equals V by 2 pi FC, C. I equals CV, D. I equals V by C. Answer: A. I equals 2 pi FCV. Question 9. The energy stored in a capacitor is given by A. 1/2 Li squared, B. 1/2 CV squared, C. Li, D. CV. Answer: B. 1/2 CV squared. Question 10. Capacitors are used in circuits to A. Oppose changes in voltage, B. Store electrical energy in an electric field, C. Filter out low frequency signals, D. All of the above. Answer: D. All of the above. Would you like AC voltage applied to a series LCR circuit? Objective questions. Question 1. A series LCR circuit consists of A. Resistor, inductor and capacitor connected in series, B. Resistor, inductor and capacitor connected in parallel, C. Resistor and inductor connected in series, D. Resistor and capacitor connected in series. Answer: A. Resistor, inductor and capacitor connected in series. Question 2. The impedance Z of a series LCR circuit is given by A. Z equals R plus XL plus XC, B. Z equals square root R squared plus XL XC squared, C. Z equals square root R squared plus XL squared plus XC squared, D. Z equals R by of XL plus XC. Answer: B. Z equals square root R squared plus XL XC squared. Question 3. The phase angle phi between the voltage and current in a series LCR circuit is given by A. Tan phi equals XL XC by R, B. Tan phi equals XC XL by R, C. Tan phi equals R by of XL XC, D. Tan phi equals R by of XC XL. Answer: A. Tan phi equals XL XC by R. Question 4. In a series LCR circuit at resonance, the ball and jeshi, A. Impedance is maximum, B. Impedance is minimum, C. Current is minimum, D. Voltage is maximum. Answer: B. Impedance is minimum. Question 5. The resonant frequency of a series LCR circuit is given by A. F equals 1 by 2 pi square root LC, B. F equals 2 pi square root LC, C. F equals 1 by LC, D. F equals LC. Answer: A. F equals 1 by 2 pi square root LC. Question 6. At resonance, the power factor of a series LCR circuit is A. 0, B. 0.5, C. 1, D. Depends on the values of L, C and R. Answer: C. 1. Question 7. In a series LCR circuit, the current A. leads the voltage always, B. lags the voltage always, C. can lead or lag the voltage depending on the values of L, C and R, D. is always in phase with the voltage. Answer: C. can lead or lag the voltage depending on the values of L, C and R. Question 8. The quality factor Q of a series LCR circuit is a measure of its A. resonance sharpness, B. power dissipation, C. impedance, D. phase angle. Answer: A. resonance sharpness. Question 9. In a series LCR circuit, the voltage across the inductor and capacitor can be A. equal and opposite, B. equal and in phase, C. unequal and in phase. Power in AC circuits and power factor. Objective questions. Question 1. The average power consumed in a pure resistive AC circuit is given by A. P equals VI, B. P equals VI cos phi, C. P equals I squared R, D. all of the above. Answer: D. all of the above. Question 2. The power factor of a circuit is defined as A. the ratio of true power to apparent power, B. The ratio of apparent power to true power. C. The ratio of reactive power to apparent power. D. The ratio of true power to reactive power. Answer A. The ratio of true power to apparent power. Question 3. The power factor of a purely resistive circuit is A. 0, B. 0.5, C. 1, D. Depends on the frequency. Answer C. 1. Question 4. The power factor of a purely inductive or capacitive circuit is A. 0, B. 0.5, C. 1, D. Depends on the frequency. Answer A. 0. Question 5. In an AC circuit, the power factor is unity when A. The circuit is purely resistive. B. The circuit is purely inductive. C. The circuit is purely capacitive. D. The circuit is inductive and capacitive. Answer A. The circuit is purely resistive. Question 6. The power factor of a circuit can be improved by A. Adding a capacitor in series. B. Adding an inductor in series. C. Increasing the frequency of the AC supply. D. Decreasing the frequency of the AC supply. Answer A. Adding a capacitor in series. Question 7. The apparent power in an AC circuit is given by A. P equals VI. B. P equals VI cos phi. C. P equals I squared R. D. P equals V squared R. Answer A. P equals VI. Question 8. The reactive power in an AC circuit is given by A. P equals VI. B. P equals VI sin phi. C. P equals I squared R. D. P equals V squared R. Answer B. P equals VI sin phi. Question 9. The true power consumed in an AC circuit is given by A. P equals VI. B. P equals VI cos phi. C. P equals I squared R. D. P equals V squared R. Answer B. P equals VI cos phi. Question 10. A wattmeter measures A. Apparent power kite A. B. True power kite A. C. Reactive power. D. Power factor. Answer B. True power. Would you like more questions or do you have any? Transformer. Objective questions. Question 1. A transformer works on the principle of A. Self-induction. B. Mutual induction. C. Electromagnetic damping. D. Eddy currents. Answer B. Mutual induction. Question 2. A transformer is used to A. Step up or step down voltage. B. Convert AC to DC. C. Convert DC to AC. D. Amplify current. Answer A. Step up or step down voltage. Question 3. The ratio of the number of turns in the primary and secondary coils of a transformer is called A. Turns ratio. B. Voltage ratio. C. Current ratio. D. Power ratio. Answer A. Turns ratio. Question 4. In a step-up transformer, the number of turns in the secondary coil is A. Less than the number of turns in the primary coil. B. Greater than the number of turns in the primary coil. C. Equal to the number of turns in the primary coil. D. None of the above. Answer B. Greater than the number of turns in the primary coil. Question 5. In an ideal transformer, the power input is A. Less than the power output. B. Greater than the power output. C. Equal to the power output. D. None of the above. Answer C. Equal to the power output. Question 6. The efficiency of a transformer is given by A. Output power / input power. B. Input power / output power. C. Voltage ratio. D. Current ratio. Answer A. Output power / input power. Question 7. Eddy currents in the core of a transformer can be reduced by A. Using a laminated core. B. Using a solid core. C. Increasing the number of turns. D. Decreasing the number of turns. Answer A. Using a laminated core. Question 8. A transformer cannot be used to A. Step up voltage. B. Step down voltage. C. Convert AC to DC. D. Match impedances. Answer C. Convert AC to DC. Question 9. The core of a transformer is made of A. Copper. B. Aluminum. C. Soft iron. D. Steel. Answer C. Soft iron. Question 10. Transformers are used in A. Power transmission. B. Electrical appliances. C. Electronic circuits. D. All of the above. Answer D. All of the above. Would you like more questions or do you have any